Have you ever looked up at the sky and seen a helicopter buzzing like a giant dragonfly? These incredible flying machines are truly special. Unlike airplanes that need a long runway, a helicopter can take off and land straight up and down. It can hover in one spot, fly forwards, backwards, and even sideways. It's like a magical carpet but powered by science. How did we come up with such a brilliant invention? It's a story that spans centuries and started with a simple toy. Get ready to explore the amazing world of helicopters, and don't forget to subscribe to our channel, Academic 51, for more awesome science adventures. The journey begins over 2,000 years ago in ancient China. Imagine a simple bamboo stick with a propeller on top. When you spun the stick between your hands and let it go, it would fly up into the air. This little toy, called a bamboo copter or Chinese top, was the very first idea of vertical flight. Fast forward to the 1480s in Italy, where the brilliant artist and inventor Leonardo da Vinci sketched a design for what he called an aerial screw. It looked like a giant corkscrew and was designed to bore its way into the air. While it was never built, Da Vinci's idea showed he understood the basic principle of using a rotating wing to create lift. For centuries, these ideas remained just dreams and drawings. It wasn't until the early 20th century that real progress began. In 1907, a French inventor named Paul Cornu managed to lift a machine off the ground for a few seconds using two rotating blades. His flight was wobbly and didn't last long, but it was the first time a person had ever flown in a helicopter. Then, in 1936, Germany's Focke-Wulf FW-61 became the first truly practical helicopter. It could fly for over an hour and was much more stable than earlier designs. It showed the world that helicopters were not just a fantasy anymore. The real breakthrough, however, came from a Russian-American engineer named Igor Sikorsky. In 1939 he flew his VS-300, a machine that set the standard for modern helicopters. It had a single main rotor on top and a smaller tail rotor at the back to keep it stable, a design that is still used all over the world today. Sikorsky's invention proved that helicopters could be reliable and controlled with precision. From a simple spinning toy to a sophisticated flying machine, the helicopter had finally arrived, ready to change the world in ways no one could have imagined. So, how does a helicopter defy gravity and dance in the air? It's all about the main rotor, those long spinning blades on top. Think of them as rotating wings. As the engine spins the rotor at incredible speeds, the blades are shaped to push air downwards. According to a cool rule of physics called Newton's third law, for every action, there is an equal and opposite reaction. So, as the blades push a massive amount of air down, the air pushes the helicopter up. This upward force is called lift, and when it's stronger than the pull of gravity, the helicopter rises into the sky. Of course, spinning those huge blades requires a lot of power. That's where the engine comes in. Most modern helicopters use a powerful jet engine called a turboshaft engine. This engine doesn't push the helicopter forward like an airplane's jet engine does. Instead, it uses its power to turn a series of gears in a gearbox, also known as the transmission. The transmission's job is to make the main rotor spin very, very fast while the engine runs at its own best speed. It's like the gears on a bicycle, helping the pilot get the most power out of the engine to turn the rotors efficiently. Now, if you only had a big spinning rotor on top, the helicopter's body would spin wildly in the opposite direction. That would be a very dizzying ride. To stop this from happening, helicopters have a smaller rotor on the tail, called the tail rotor. This little rotor spins vertically and pushes air sideways, creating a force that pushes against the main body's urge to spin. It acts like a rudder, keeping the helicopter straight and balanced. By changing the speed of the tail rotor, the pilot can even use it to turn the helicopter left or right while hovering. Pilots control all of this from the cockpit using a set of special controls. They use a stick called the cyclic to tilt the main rotor blades, which makes the helicopter fly forwards, backwards, or sideways. To go up or down, they use a lever called the collective, which changes the angle of all the blades at once to increase or decrease lift. And to control the tail rotor and point the nose of the helicopter, they use foot pedals. It takes a lot of skill and coordination, but these controls allow pilots to perform amazing maneuvers that no other aircraft can. Let's take a closer look at a helicopter and its main parts, almost like a science checkup. The most obvious parts are, of course, the rotors. The big one on top is the main rotor, and the small one at the back is the tail rotor. These are the helicopter's wings and rudder, all rolled into one amazing system. But what connects them all? That's the job of the fuselage, which is the main body of the helicopter. It's where you'll find the cockpit, the cabin for passengers or cargo, the engine and the fuel tanks. It's the skeleton that holds everything together in one piece. Inside the cockpit, you'll find the pilot's office. This is where all the controls are. We already mentioned the cyclic stick and the collective lever, which the pilot uses to direct the helicopter. There are also the foot pedals for the tail rotor. The cockpit is filled with instruments and screens that tell the pilot everything they need to know: how high they are, how fast they're going, how much fuel is left, and whether the engine is running properly. It's the nerve center of the entire machine, where the pilot makes all the decisions to fly safely and precisely. Now, how do the pilot's controls actually change what the big rotor is doing? The secret is a brilliant piece of engineering called the swash plate. This device sits at the top of the main mast just below the rotor blades. It's made of two plates, one that spins with the rotor and one that doesn't. When the pilot moves the cyclic stick, the stationary plate tilts. This tilt is transferred to the spinning plate, which then adjusts the angle of each blade as it goes around. This clever mechanism allows the pilot to precisely control the direction of the lift, making the helicopter move in any direction. Finally, every helicopter needs a way to land. Some have wheels, just like an airplane, which are useful for moving around on the ground. These are often called landing gear, but many helicopters have simple metal tubes called skids. Skids are strong, lightweight, and perfect for landing on uneven or soft surfaces like grass, snow, or a rocky mountainside where wheels might get stuck. From the complex swash plate to the simple landing skids, every part of a helicopter has a crucial job to do, working together to make vertical flight possible and safe for everyone on board. Helicopters aren't just for fun joyrides, they are some of the hardest working machines in the world and play vital roles in our society every single day. One of their most important jobs is search and rescue. When someone is lost in the mountains, stranded by a flood, or needs to be rescued from a ship at sea, a helicopter is often the only way to reach them. They can hover over difficult terrain and use a winch to lower a rescuer or lift a person to safety. These air ambulance helicopters are flying hospitals, saving lives when every second counts. They are also essential for all sorts of work in remote places. Imagine trying to build a new ski lift on top of a mountain, or repair a power line in a dense forest. Carrying heavy equipment to these locations would be nearly impossible by land. Helicopters can act as sky cranes, lifting heavy materials like steel beams, concrete, and electrical towers and placing them with incredible precision. They also transport workers and supplies to offshore oil rigs far out in the ocean, a job that would be slow and difficult for boats, especially in rough seas. Of course, helicopters are also used for transport and tourism. In big, crowded cities like New York or Sao Paulo, helicopters provide a fast way for people to travel from airports to the city center, flying high above the traffic jams on the ground. They also offer breathtaking sightseeing tours, giving people a bird's-eye view of famous landmarks like the Grand Canyon, Niagara Falls, or the London skyline. They allow us to see our world from a completely new and exciting perspective that was once only available to birds. From their beginnings as a simple toy in ancient China, helicopters have evolved into powerful and versatile machines that help us in countless ways. We've seen how they fly using lift from their main rotor and stay balanced with their tail rotor. We've looked at their key parts, from the engine to the landing skids, whether they are fighting fires from the air, reporting on traffic, helping farmers spray their crops, or serving in military operations. Helicopters have become an indispensable part of modern life. They are true marvels of engineering, buzzing in our skies as helpers, rescuers, and explorers. We hope you enjoyed this flight through the world of helicopters. Don't forget to subscribe to Academic 51.